button-controlled vending machine using servomotor with LCD display and RFID verification. Description: this project aims to develop a vending machine that dispenses an item through the use of a servomotor when a button is pressed. Additionally, this machine has a LCD display and requires RFID verification to ensure that only allowed individuals are able to access the items.
Materials include Arduino Uno R3, jumper wires, resistors, 3 pieces of continuous microservomotor, 16x2 LCD module, an RFID RC522 card reader module, an RFID card, and 3 pieces of push buttons.
So, how does this project work? First, an LCD module displays the text, vending machine, and press a button. Then, the system checks if button 1 was pressed. If yes, LCD module displays item 1 selected and tap RFID card. Then, the system checks if RFID card was tapped. If no, it checks again until it is tapped. Next, the system checks if RFID card is valid. If yes, LCD module displays dispensing and thank you as servomotor 1 rotates. If no, LCD module displays invalid RFID card and servomotor 1 does not rotate. Then, the whole process starts over. Now, if button 1 was not pressed, the system will check if button 2 was pressed. Then, the process the same as button 1 will proceed, but this time, the LCD will display item 2 selected and the servomotor that will move or will not move is servomotor 2. Then, the whole process starts over. Now, if button 1 or button 2 was not pressed, the system will check if button 3 is pressed and the process that is the same as button 1 and button 2 will proceed, but this time the LCD module will display item 3 selected and the servomotor that will move or not move is servomotor 3. While if no button was pressed, the whole process will just start over. Now, proceeding on the code and code breakdown. The first is library imports. These libraries let the Arduino talk to each component. SPI.h is used for communicating between Arduino and RFID reader MFRC522, while MFRC522.h controls the RFID module. Next, Servo.h controls servomotors that is used for dispensing. And lastly, Wire.h and liquid crystal I2C.h controls the I2C LCD display. Next is the component setup. It defines which Arduino pins are connected to the RFID module, sets up the LCD using the I2C address 0x27, and creates 3 servo subjects for the 3 servo motors. Button pin definitions. Here, each button corresponds to a product selection. Button 1 for item 1, button 2 for item 2, and button 3 for item 3. When pressed, the system will start the process flow for that item. Authorized RFID card UID. This is the unique ID of the valid RFID card. When scanned, the program compares the scanned UID with this stored one to check access. Setup function. It initializes all components. It starts serial monitor, starts communication with RFID and LCD, connects servos to pin 3, 5, and 6, sets button as input pull-up, meaning they read high normally and low when pressed. And lastly, displays a welcome message on the LCD. Main loop. It continuously checks if any button is pressed. If a button is detected to be low or pressed, it calls handle selection item number to start that item's process flow. And also, the small delay or 200 ms prevents button bouncing or false multiple triggers. Item selection and RFID verification. What happens here is that LCD displays which item was selected. Then, it prompts user to scan their RFID card. Then, the system waits for a RFID card to scan. If authorized, it proceeds to dispensing, while if invalid, it shows access denied and resets to start. Checking RFID authorization. Here, the system reads the RFID card's unique ID bytes and compares them with the stored authorized UID. If all bytes matched, returns true. Then, prints the UID to the serial monitor for debugging. And lastly, stops the RFID reader from reading continuously. Dispensing function. This controls the continuous rotation servo. Servo write 0, this means full speed in one direction or dispensing, while servo write 90 stops the rotation. The delayed duration of 1000 ms determines how long it spins. This can be adjusted.
This project offers a safe and automated vending machine through the combination of RFID verification and servomotor controlled item dispensing, akin to current RFID-enabled vending prototypes that substitute traditional payment with secure user authentication. The main beneficiaries consist of school and workplaces, as it guarantees that only permitted individuals can access resources, improving both safety and operational effectiveness. The system is both economical and scalable, consistent with studies indicating that IoT-enabled dispensing solutions lower costs and enhance efficiency, while also providing significant practical learning experiences in programming, electronics, and automation for students and staff. Moreover, this technology showcases the wider progression of vending systems towards intelligent, connected solutions that incorporate RFID and automation. Its real-world uses encompass the regulated allocation of materials, facilitating efficient procedures, and protecting assets in multiple settings.